I just want to look at this first one, 2011 question 2a. So in this one, you were given two roads that intersected at angle theta here. And you were told that the tan of theta was 4/3, which meant then that theta was 53.13 degrees. So you know that. Now, car A is along here and car B is travelling along this road. This is moving with a speed of 5 and this is moving with the speed of 10. And then you had to find the velocity of A relative to B. So you had to find the VAB. So you correctly said that VA was 5I plus 0J. And VB. Now, to find VB, remember, what you're going to do is to draw a right angle triangle maybe around this one here. So this would be your J component, this would be your I component. So the I component would become 10 cos theta on the I, and this one 10 sine theta on the J. And when you work all that out, when you get your I's, your VB becomes 6I plus 8J. And your VA, as we said, was 5I plus 0J. So this is VA, 5I plus 0J, and VB, 6I plus 8J when you work it all out. And then your VAB, you found to be minus I minus 8J. What's your signs when you're subtracting the VA and B? Your magnitude, everyone got that correct, root 65. And of course your direction then becomes arc tan J's over the I's 8/1. And when you work that out, you get an angle of, I'll call it alpha, of 82.87 degrees. Okay, so you do all of that and you've got to find the shortest distance. So you're going to take your VAB line and put it into the diagram. Now the VAB has an angle of 82.87, and if I were to just draw a vertical line here for my j-axis, we'll say, remember that when I put this VAB in, it's going to make an angle of 82.87 with, of course, that I-axis. So, which means if I want an angle of 82.87, it's going to be bigger than 53.13. So it will be this kind of thing. This is where you need a nice big diagram. So this will be your VAB. This angle here is 82.87, which means that if I just extend this axis over that side, this angle over here is also the same, 82.87. I know that, again, looking at my opposite angles, this one's theta by the opposite angle rule, which means that this angle here, I'll call it dot. Angle dot will be 82.87 minus 53.13. And that gives you 29.75, we'll say. So dot is 29.75 degrees. Now, you had to move A to the intersection, and that took 10 seconds, or took 20 seconds, because it was travelling at 5 metres per second, and it was 100 metres from the intersection. In that same time, B moved on 200 metres, so it was 100 metres from the intersection, so it moved on another 100 past. So this is your intersection line now, that black line. So B now is up here somewhere. And it's 100 metres from the intersection. So when you drop that perpendicular, that D, that's going to be your closest distance, the shortest distance between the cars. So D, the sine of theta is D over this distance here, which is 100, which means that D is 100 times the sine of 29.75. And when you get that, you get 49.6 metres. Okay, so that was the first part. That was part A. Now, let's look at part B. Part B for this one, you could do it using trigonometry. It was quite a nice one. So you had a woman crossing a river, 80 metres wide. Remember, she has to land between B and C. So B is if she has to land straight across. So if she's going to land straight across, she's going to obviously head this way in order to go straight across. And of course, this is her heading angle here, theta. We know that she's going to row at 4 metres per second, which means the river's going to push her down at 3.5 metres per second. So I'll be able to get theta here. And once I do that, I'll know that theta is 3.5 over 4. We'll say the opposite over the. So this is my theta. That's my, yeah, so if I say the cos of theta is 3.5 over 4, that will give me a theta of 28.955 degrees. So that was the first angle. Now, the other thing is if she wants to go over to C, so this time she wants to go over here, so she's going to head that way because the boat's going to push her that way at 3, the river's going to push her that way at 4.5. Now, if I had an angle here, that would be very handy. So what I'll do is I'll use the distances that I have. Now, remember, I have a distance of 80 across. And this distance downstream, I'm told this in the question, from B to C, that distance downstream is 20 root 3. So this distance down here is 20 root 3. So once I have that, I'm able to find... let's say this angle here, if I call this one theta, I'll call it theta, okay. So the tan of theta will be the opposite over the adjacent, so I'll be able to find theta. Once I have theta, I'll be able to get into this black triangle here, I'll call this alpha. So I'll find theta, then I'll subtract it from 180 to get alpha, and now I can use sine rule because I'm in that black triangle. So sine rule will get me this angle here, I'll call that beta. And once I have beta, remember by the alternate rule, this angle down here is alpha. So I can use sine rule then. Sine rule will give me beta. And then once I have beta, I already have alpha, I'll be able to find this angle over here. What will I call this? I'll call this angle A for the time being. So you'll get angle A then. And that will be the second value for theta in order for that boat to get down to position C. So you're first of all going to use the blue triangle to get you that angle theta, then you get into the black triangle and you can use sine rule. That's a nice little question.